Okay, somebody tell me, just name one thing that these four, 1, 2, 3, and 4, name one thing that they have in common.
They have the same asymptote of 2.
Excellent. They have the same asymptote of 2, and then I also heard they have the same y-intercept. They do have the same y-intercept except for the last one, y4, and that we'll explain that a little bit more with the answer to the next question, actually. So I'm going to go ahead and put up my table. Looks like that. Now yours, you probably didn't put question marks in. You probably put error, right?
Yes.
So the next question actually asks, why does that fourth function have undefined values? So why does that fourth function have undefined values?
Because that one doesn't
There's no base.
go to -1.
Well, there is a base, but it's a base of 0.
Anything times 0 is 0.
Well, that is true. But this is raising the 0 to a something power, right? And we can raise 0 to the first power. When we raise 0 to the first power, we get 0, and then 0 times whatever, and then they add 2, and you get that. But what happens if I do 0 to the -1 power? Let's see, 0 to the -1 power. What does that to the -1 tell me I need to do? What do I do with negative exponents?
Divide by 0. Or no.
Cut them over 1.
Put it, like, right now he's unhappy.
1 over.
Right, he's unhappy. He lives upstairs and he's unhappy. So now I have to move him down here.
You can't divide by
Ah, now what am I doing?
Divided by the
Dividing by 0, and you can't divide by 0. If it was 0 to the -2 power, that would be 1 over 0 squared, and you're still dividing by 0. And you can't divide by 0. So that's why these quantities don't exist. And these quantities are just 0, like Bass said. You're multiplying 0 over and over again, 0 times 0 times 0 times 0, and then you just add 2 to it every time. So it creates a horizontal line on that fourth one. That's why that one doesn't have the same y-intercept, because it has a base of 0. So you can't really have that base of 0 like that. It just doesn't work. It's just not a good exponential function. And then the next part, go ahead and set your window and everything like the next one, and put that function in your calculator. And I'm going to put it in mine also. And we're going to look at it together, because I think this is a really good explanation. They kind of have the window set a little bit weird. Yes? Oh, yes ma'am, sorry. Okay, so I plugged it in my calculator, and then I went ahead and set my window like they asked for you to set the window. And then if I hit graph, I get all these little tiny dots. You see that? Is that what you got? Or are y'all still filling in the table? I'm sorry. I didn't mean to jump ahead of you. But when you hit graph, if you'll notice, I get little dots on top and on bottom. So the question is, why do I think that the graph of this function has to be represented by individual discrete points rather than a continuous curved line? And we kind of talked about this a little bit with Are You Able at the Table in that Think About It section. What happens when my base is -4?
The graph is weird.
It's what?
The graph is weird.
The graph's weird.
Like those ways.
Yeah, it would be up and down and up and down. Because -4 squared would be positive, right? Positive 16. But -4 to the third power would be -64. So you're talking about going back and forth between positives and negatives. So they can't really connect the lines. It has to just be these individual dots in each place. So now the next thing, on D, it asks you on this screen, so once you have your graph screen up, to go ahead and hit trace. And I've already moved my cursor to the left. But it tells you to just move your cursor right. I'm going to move my back to the right real fast. Okay, so now my cursor's right in the middle at 0, 0. And if I move it right, now watch what happens. It's moving by 0.1. When I hit it, see, notice the X went to 0.1. My cursor is gone. Now when I hit 0.2, my cursor comes back. 0.3, 0.4, 0.5, 0.6. Why do you think that happens?
It's a mean.
There's nothing there. And I'll show you why real fast. Because what is 0.1? What is that? 0.1.
Over 100.
1 over 100?
1/10.
1/10, right? 0.1 is 1/10. So what they really said to me is -4 to the 1/10 power. Well, we learned what that means. Remember bottom in the crack? Yes?
The crack.
So that means the 10th root of -4. Can you take the 10th root of -4? What kind of number is that?
Negative.
Tiny.
Imaginary. It's imaginary.
Oh yeah.
Can you take the square root of the 10th root of -4?
No.
No. But then what about this? -4.2. What is 0.2?
That
That's
is.
what we were to.
2/10, which reduces to
Yeah.
1/5. Okay, so which really means bottom in the crack. The 5th root of -4. Can I take the 5th root of -4?
No. Yes.
Yes, you can.
Why?
Because it's odd. You can take, because -4 times -4 times -4 times -4 times -4
Oh.
is going to give me a negative answer. So you can take the fifth, you can take the odd roots. You can't take even roots of negative numbers. But you can take odd roots of negative numbers. Like -27. What's the cube root of -27? -3. 27. What's the cube root of +27?
2.
+3, right? You can take a negative cube root. You can take a negative 5th root. Can I take a negative 6th root? No, because that's even. Can I take a negative 7th root?
Yes.
Yes. So it's every other one that you can't take, which is why this disappears every other time. So we said it on Friday when we talked about are you able with the table? You won't have a negative b value, a negative base. And this is why. Because it goes undefined every other time. You can't have that. So because of that, we're not going to use a negative base. Your bases will always be between 0 and infinity.